Hello, I am Byung, the author of this paper. I am a PhD student at Gwangwon University in Seoul, Korea. The other Joon is my advisor. He is a professor at Gwangwon University. In order of paper, I will present in order of introduction, related works, experiments, and conclusion. The problem to be solved in this study is to detect numeric text in analog power mirror images. In this study, object detection models are used. Object detection is the task of finding the location and ranges of specific objects in an image. We use the well-known object detection models YOLO and Faster RCNN. Both YOLO and Faster RCNN use deep neural networks. To solve the problem of this study with YOLO and Faster RCNN, it is necessary to generate a new model. It takes a lot of training time to generate a high-performance model. We propose a training technique that can reduce training time while maintaining high performance. The usage of analog power mirrors is recorded by manpower. The purpose of this study is to record usage using machines. Humans only need to take pictures with a smartphone. Two processes are required to record usage using machines. The first process is to detect the portion of usage in the image. The second process is to recognize the numbers. We only deal with the problem of detection. We are targeting analog power mirrors with a numeric dial indicating usage, and various texts are mixed in the mirror image. The text to be detected is the portion corresponding to the usage. It is in a black box and 4 white numbers. There is another paper that detects power mirror usage. It is a paper published by Joon, Byung, et al. They targeted digital power mirror images. It has a 7-segment liquid crystal display. Joon's study used image processing called grain. They recognized the rectangle screen in the grain image. Joon's study has a similar purpose to ours, but the approach is different. And another related work is license plate recognition. License plate recognition is a topic that detects license plate in car images and recognize numbers and letters on the plate. License plate recognition is an old research field, but recently many license plate recognition studies use deep neural networks. They are the same approach as ours. Our study applied object detection to a power mirror. Object detection is a topic of computer vision. The main goal of object detection is to return the locations and ranges of the objects in the images. Usually, an image with bounding boxes added is output. The machine used in the experiments has 4 GPUs. GPUs are NVIDIA GTX 1080 Ti. Each GPU has 11 GB of memory. We use YOLO and Faster RCNN. They are well-known object detection models. We used a model implemented with the TensorFlow library and did not use pre-trained models. Datasets consist of pair of image file and XML file. The resolution of each image is 2160 by 2160. They are RGB color images. XML files with the same file name as the image contain the location information of the object. They are in Pascal VOC format. Images are 2 types of mirror images used in Korea. There are 6,000 images for each mirror. We will refer to the mirror dataset of one time as mirror 1 and the dataset of the other mirror as mirror 2. And we will refer to the union of the 2 datasets as mirror 1 plus mirror 2. We used 1/10 of each dataset for training and tested the rest. And the running rate is 0.0001 and the batch size is 12. Each training set trained 400 epochs. We measured the detection performance as follows. If bounding box contains all 4 numbers, it is correctly detected. If the bounding box contains 3 or fewer numbers, it is incorrectly detected. If there is no bounding box, it is incorrectly detected. And detection speed is the average time used to detect. As a result of the experiment, YOLO has slightly better detection performance than faster RCNN, and the detection speed was almost twice as fast. Table 3 shows the detection performance when training 200, 300, and 400 epochs. Detection performance has been improved to 400 epochs. After that, it did not increase anymore. We trained by reducing the resolution of image. The image resolution of the training data was reduced by 416 by 416. The image resolution of the test data was not reduced. Other training factors are the same as in the previous experiment. We trained only the YOLO model that performed better. As a result of experiment, detection performance decreased slightly. The training time was significantly reduced. We trained while reducing the amount of training data to 600, 300, and 200. Instead, the number of epochs was increased to 400, 1000, and 1500. Training image resolution is 416 by 416. As a result of the experiments, the model trained by reducing the number of images from 1200 to 600 cut the training time in half while maintaining detection performance. And the model that trained 1000 epochs with 300 images showed 99.85% of detection performance. Each training time is 24 minutes longer than the model trained with 600 images. However, we recommended this method. But it takes much longer than 24 minutes to create 300 datasets. YOLO has slightly better detection performance and faster detection speed than faster RCNN. Both models require over 400 epochs of training with 1200 images to reach a detection performance of over 99%. In the case of YOLO, even if the resolution of the training image is reduced to 416 by 416, the detection performance is almost unchanged. However, training time can be significantly reduced. The YOLO model, which trained 1000 epochs with 300 images, can achieve more than 99% detection performance. It is the most efficient training technique. Thank you.